The topic which we are going to discuss today is sets. Nowadays, the concept of set theory is being used in almost all the branches of mathematics. We will be covering this topic in 4 parts, in which we will discuss what are sets, how do we represent them, some basic definitions of different types of sets, operations on sets. Today, we are going to discuss what are sets and how do we represent them. Suppose we have to collect some students from a locality. Now, in this collection, can we be sure whether a given child has been included or not? Of course, we cannot be sure. On the contrary, suppose we take the collection of all the students of class 11 of a particular school. Now, here we are 100% sure whether a given child has been included in that collection or not. If that child is studying in that school in class 11, surely the child will be included in that collection, otherwise not. Now, these two collections are different. The first one is not properly defined and the second one is well defined. This well defined collection is known as set. Now, let us consider some numbers. Collection of even natural numbers less than or equal to 10. Of course, only these 5 numbers will be taken. No number other than these 5 will be taken in this collection. Again, suppose we collect the vowels of English alphabet, only these 5 vowels will come, A, E, I, O, U. No other letter of English alphabet will be here. These two collections are also well defined. So, the collection of these numbers and these alphabets is again an example of sets. Further, let me collect some intelligent students of a particular class. Now, let me know whether this collection is set. Of course not. Why? Because the collection of intelligent students is not well defined. One child may be intelligent according to one teacher and may not be intelligent according to the other. So, this collection is not properly defined. So, we can define the set like this. A set is a well-defined collection of objects. The sets are usually denoted by capital letters A, B, C, and elements of the set are denoted by small letters A, B, C. If X is a member of any set, means X is the element of a set, then we write like this: X belongs to A. This is a Greek symbol which is used to write belongs to, and if any element Y does not belong to the set, then we write like this. This symbol is used to represent does not belong to. So, students, we have learnt what is a set. Now, let us learn how do we represent them. Suppose we have to consider the set of all odd numbers less than 10. Then the numbers would be 1, 3, 5, 7 and 9. We list all these numbers as is shown here, separate them with commas and put them between braces, that means curly brackets. It is a way to represent a set. This way of representing the set is known as roster form or tabular form. Again, let me consider a case of set of all prime numbers. All prime numbers will start from 2, then 3, 5, 7, 11 and so on. It will go up to infinity. Indefinitely it will go. So, how can we write? We cannot write all the prime numbers. So, we put here the dots and put them between braces. Suppose we want to make the set of the letters used in the word mathematics. Then we will start listing the elements from M, A, T, H, E, M, A, T, I, C, S. Now, what do we observe here? M has come 2 times, A also and T also. But while listing the elements, we will not repeat unnecessarily. Why to use an element 2 times? We will write only once. So, M will be written only once, A also and T also. The total elements in this set will be 8 only. Again, suppose I change the order of these letters. Will it make any difference? Let us understand it with an example. A set is there containing only 4 elements, 1, 2, 3 and 4. We will list the elements in this order. Suppose I list it in the order 4, 3, 2, 1. Will it be a different set? No. Order of listing the elements in a set is immaterial. So, if the letters of the word math written, the first letter is T, the second letter is M, it will make no difference. So far, we have learned that while listing the elements in roster form, number 1, we write down all the elements of the set, separate them with commas, put them within curly brackets. Number 2, an element is written only once. We never write the same element again. Number 3, the order of listing the elements make no difference. Suppose someone asks me to write down the set of all the workers working in a factory where we have got near about 20,000 workers. Will it be possible for me to write down all the names of the workers? Because there are 20,000 workers, it will be a very tedious job. So, naturally, we must find out some method which is convenient and can be done easily. For that, we use the property possessed by all the elements of the set. Here, we are making the set of the workers working in a particular factory. So, the property is this. We will use this property and write down the set as set of all the workers working in a particular factory. It will serve our purpose, because if the workers is working in that factory, it will be included in the set, and if the worker is not employed in that factory, he or she will not be included. So, within one sentence our work will be over instead of writing 20,000 names. This method of writing the set is known as rule method or set builder form. So, to write down the set by rule method or set builder form, what we do, we find out the common property possessed by all the members of the set. We have learned earlier that every member belonging to a particular set possesses a property which is not possessed by any other object not belonging to the set, and that property is used to write down the set in set builder form. Let me find out the set of all the natural numbers less than 20. Then what is the property? Number is natural number and the number is less than 20. So, we write down the set as set of all x such that x is a natural number and less than 20. The same can be written as set of all x such that x belongs to set of natural numbers and x is less than 20. We have used symbols here to write down the set. This method of representing the set is a set builder form. The set builder form is mainly very useful when we are unable to write down the set in set builder form. Suppose I want to write down set of all real numbers lying between 3 and 5. Will it be possible for me to write down all the real numbers? No. We cannot write all the real numbers between 3 and 5 separated by commas. In that case also, we use the property to write down the set of all x such that x is a real number, x is greater than 3 and less than 5. This set will be the set of all real numbers between 3 and 5, 3 and 5 not included. By now, we have learned what are sets and two methods to represent a set. Now, using rule method, let me discuss one more set. The set is here set A, set of all x such that x square equal to minus 1 and x belongs to real number. Now, we have to find the elements belonging to this set. Is there any real number whose square is minus 1? No. There is no real number whose square is minus 1. We cannot get such a number. So, can we write any number here using roster method? We cannot write any number here. So, this is a set having no element. So, the set in which we do not have any element is known as empty set, and the empty set is denoted by this Greek letter known as phi. Definition of empty set will be then a set which does not contain any element is called empty set. Now, students, after empty set, let us consider one more set. In this set of all x, x belonging to set of natural numbers and x square minus 25 is equal to 0. Let me solve this equation. X will be equal to plus 5 and minus 5. X belongs to set of natural numbers. So, minus 5 is not a natural number. We get only one answer for the solution, and that is 5. So, this set is having only one element. Again, suppose I take the set B, set of all x such that x is even prime number. Now, I have to look for all prime numbers which are even. We have got only one even prime number, and that is 2. Again, this set is having only one element. So, these sets which are having only one element is known as singleton set. Empty set is having no element and singleton set is having one element. So, the definition can be given as a set which contains only one distinct element is known as singleton set. Today, we have learned what is a set. Set is a well-defined collection of objects. We have learned two methods of representing a set. One is set builder form and another is roster form. We have also learned what do we mean by empty set and what do we mean by singleton set.